signify by waving or talking. Brad Nelson, good. Anyone else? Oh, Dave Henderson, hey, we good?
Can you hear me actually? Hear my voice?
I took that hand wave electronically from Dave Henderson as a participant. Is that correct?
Yes, can you hear me?
Yes, very good.
Oh, good.
No video, but we hear you.
Okay.
Any other participants? We have Brad Nelson and Dave Henderson. Signify by speaking loudly or waving something. Good, this will fit just about right. So let's start out with Brad. What was your approach to Roman numerals?
This is my implementation. What I did was to rather than sort of fight with the logic of having to manage subtraction and all of that directly, I had just a string as a table for each of the different multiples of, you know, 10 and ones, tens and hundreds, and then a loop for using m's at the end. And that allows me to have this word nth that pulls out the nth element of this string, and then handles each place. So the core of it here is figuring out, I actually print a negative sign in front, and apparently the n, it was some archaic convention used in the Middle Ages for 0 in some cases. And then failing that, it goes and divides through and then prints out the thousands, hundreds, and whatnot. That lets you compactly go through. Here's a loop, you know, doing some negative numbers and then all the way into the positive numbers. So that's it.
Well, Brad, could you go back to your code, your page of code? There we go. I like to compliment Brad every time I see his code. They're all one-line definitions. That is gorgeous. You know, one thought, one line, and then the last couple lines put it all together. So that is absolutely gorgeous. Thank you. Any comments for Brad? Comments or questions?
Yeah, I have a comment, but it's not so much for Brad. 0 is an offset. It isn't an absolute. just my thoughts.
I was motivated less by the profundities of the numerics and rather by the simple problem of wanting to have something happen for every value. So, but point taken.
I know when I have $0, I am broke.
And Brad, I'm not clear on your reasoning for your color choices.
Oh, these are horrible cuts. Sorry, this is just what Vim does by default, which is horrific. It has a fourth mode, but it's sort of very arbitrary what it does. It sort of has it understands some types of comments, and I don't know. I actually almost I put a version of it in the slide here, which might have been a better that might give a better view of it. But I concluded I wanted to run it at the prompt, so prove the thing runs. All right. Any other questions? The caret BL is it skips word at a time in the string is the idea. So it's finding a particular position and then nth uses that to walk down, find the particular symbol, and then the beginning and the end of it.
What fourth were you using, Brad?
G4.
And are you ready to go on?
Yep.
Very good, thank you. Again, I love one-line definitions. Next, Dave Henderson, your approach to Roman numerals. So Dave, are you unmuted?
All right, can you see my screen now?
Yes, you're good. You're good. Good sound, screen, good sound.
Sorry about that. For now, I decided to have it eat the largest values and go on down to the smallest values and print out the symbols. So it'll try to eat 3,000s for if you have 3Ms. 3,000, it'll eat 3Ms, and then it'll proceed down to the different values. I start with 1,000, which is M, and CM for 900, and I have corresponding symbols down in the string table. So to print a symbol, I just need to know which value. And so I just walk down from largest value to smallest, or smallest to largest, and in here I find the value up here, and then I compare it to what I have left, subtract it, and print a symbol. If it is bigger, I print a symbol and subtract it. Otherwise, I just keep looping around to eat them all, and do that all the way down to the bottom. So I'm using, and then here's a test loop just to print from 10 to 1 and 990 to 1,000. And so this is my, it's a little small. I don't know if I can make it bigger. Sorry. Here's my results, and I'll run the test now. And I get one is I, and up to 1,000, which is M. And probably can make this one line, but I like it to be readable. So anyway, any questions? I found this a rather fun exercise. So remind myself of the fourth vocabulary.
Good.
If no questions, thank you very much. I appreciate being able to present.
Very nice. I too am a fan of pretty printing. Sorry.
Okay, Dave, can you, stop, okay, we'll do the stop sharing. I found the button. Very good. All right, any other participants in the challenge before I do a wrap up? Hearing none, we will. Let's see, Roman. Oops. All right, here's my offering. So as we saw the challenge, numbers to Roman numerals, decimal numbers, Roman numerals. So we have to stop and think about the first principles. The Roman numerals are based on what's called biquinary, where each decimal decade is represented by two symbols, one or two symbols. I guess it's artifact of the fact that you got 5 fingers on one hand and 10 fingers for all hands. So if your left hand represents one symbol, your right hand represents the other symbol. I think that's probably where it came from. So in this case, in the units area, the one symbol would be V and the other symbol would be I. So between the V and the I, you can make up the first decade. But we then find out some shortcuts. Instead of 4 being I, it's IV, and the 9, of course, we know is IX. Now, in Roman carvings and buildings, for example, in the Forum in Rome, they actually use both. Gate, if I remember right from memory, gate 39 is actually represented by the 3 X's, and 9 is a VIII. So even in Roman times, they used a mix. Maybe the instruction manual hadn't gotten around yet. So as we've seen in the 2 presentations, whenever you have a decimal number ending in 4, you substitute the number 1, and I'm using quintades representing each pair of symbols, like the IV would be a quintade, a group of 5, and for 10 or for 50, for 10 it would be X and L, which is 10 and 50. So if it ends in a 4, number ends in a 4, then you substitute the quintade symbol 1 level ahead. That is, 1 becomes a V. For a decimal number ending in 9, you go 2 quintades ahead. So I is jumped 2 symbols ahead to X. 100, which is C, would be jumped 2 quintades ahead, which would be D, which is 50. So we have to make these 2 irregularities for the number 4 and the number 9. So here's a pseudocode. We create the table of numerals, we get a decimal number, we set up an output buffer, and then we process over 4 decimal digits, low order first, loop, close it out. Now, a very important point here is I want to use what's available. And so the 4th numeric conversion uses pad, and it uses a couple of symbols to do that. And so I am using pad, and I'm outputting numbers just as you would if you were doing decimal conversion. You're starting low order to high and over 4 decades. So there's a do loop that runs over 4 loops. Each one is a decade. We end up dividing by 10, taking the modulo, and so on. So this is a mirror image or a replica of the 4th techniques, except the symbol set is no longer number 0 through 9, but it's the Roman letter sets. The process is really quite simple. We open the output buffer. We specify the quintade range, which is 4, which is your decimal digits. So you've got units, hundreds, thousands, units, tens, hundreds, and thousands. So that's the range. Do loop by 4. Then we just divide by 10, take the modulo and take the quotient and the remainder, look them up in a case statement, find a couple characters and append them. Now, one thing on this that is tricky, I'll mention it before we get to it, is the do loop in this case is not running over integers 0 through 4 or 0 through 3. It actually is running over the addresses in a conversion table. So at the beginning, I set up the table, and then the do loop range is indexing within that table. This turns out makes a very nice simplification. So the first step is we create the R table, a Roman table, and just put the characters in place, I, V, X, L, C, D, and M. These are on character values. Later, the loop is going to run by memory byte addresses, and so the table is constructed as byte addresses. We have a case statement. This covers our 10 situations. For X, of course, we do nothing. It's a blank. For 1, 2, and 3, we just add that same current character 1, 2, or 3 times. For 4, we add 1 character higher and then the current character. That is, it becomes IV. For 5, we click 1 address space higher. I jumps to V. 6, 7, and 8, we take 1, 2, 3 of the current character and then jump 1 character higher. to get to VI or VII. And finally for 9, we go 2 characters higher. So this, from the unit situation, we jump 2 characters ahead, which is to the tens or X situation. And here's the case statement. It really comes out quite beautiful and quite simply. In the case of 0, we drop the input parameter and do nothing. For the case of 4, we get 1 character higher, that the dupe 1 plus is 1 character higher, and we hold it. And this is typically done in the 4th pad numeric conversion. So for 4, we get the character higher, and then the current character, and then 5 is the character higher. Now remember also, it's slightly confusing because this is done right to left. Finally, down at the bottom, the default is 1, 2, or 3. We just hold that many characters. We either hold 1, 2, or 3 characters. So again, the work, all the work is being done in this case statement. What this does is it brings our conversion down to 1 command. So this entire conversion is the case statement and the command to Roman. So to Roman, we see the greater than hash sign, which begins the output buffer. This rtable section sets up the loop range. And then over do 4 times, we divide by 10, little manipulation. We go to selector, which is the case statement. That in places the characters, and then we loop by character pairs. So the do loop goes from I to X to C to M. And then finally, we close the output buffer. Closing the output buffer, it gives us the address and count. And here is the result. Oh, the spacing didn't come out very nicely. Okay. I also developed an R.R command word, which does write justification. So normally this thing should show up as a beautiful set of tables where the were organized by the quintade. Do we have any questions? Come now. What we've seen here is again, the dramatically different solution methods, which are not imposed by the language. The language in this case doesn't force us into a given sort of a solution set. It's the approach that the author uses. Any other comments, questions? Okay, I'll turn it back to Kevin.
Okay, I wanted to point out for those of you that are having dropouts or other problems like I am, that the entire presentation is being recorded, and 4th day will be on the SVFig YouTube channel in due course. It won't be 10 minutes after the end of the Zoom, but it will be soon as these things go. So the next segment is the 4th trivia contest, and it looks like it's really going to be a hoot. I've been looking forward to this ever since Bill mentioned it. So back to you, Bill.
Good. Okay, team. Today we're going to do the 4th Jeopardy. This is in the traditional form of Jeopardy that we'll use. In a few moments, I'll start the screen on that. I'm sure most of you are familiar with the methods of Jeopardy, and we will do some slight variations on that, which I shall describe.